Remind everybody, this Thursday is parent-teacher conferences. So I'll be staying late. I think we're here till like 8 p.m., like 4:15 to 8 p.m., I think is what it is, or 7:45. It's somewhere in there, 4:15 to 7:45 at least. We'll be up here at BHS in the virtual school wing. We have our own wing up here in BHS. So you and or your parents are invited to come by, and we'll be here. All the virtual teachers will be here, so you can visit with anything you would like to check out. If your parents just want to come meet us, we're here. So that is available this Thursday. All right, let's take a look at what this week involves on our lesson. All right, Algebra 3. So let's go to our grade screen. And see, we have two things this week. We have hyperbolas and a conics collage. And these are both lesson 603. So there's only one lesson, but there's two assignments. The hyperbolas is just a 4-question multiple choice, but you have the collage to do this week. So that'll take you some more time. And it's worth more points. So let's look at 6.03 lesson then. There we go. Hyperbola's lesson right there, 6.03. Okay, this is continuing our conics. You know, we looked at the parabola and we looked at the ellipse. Now we're going to look at hyperbola. So if you recall, when we looked at an ellipse last week, that's the set of all points, x and y, that the sum of the distances between the foci and a point on the ellipse is constant, right? So there's two focus points. And the distance from any point on the ellipse to those two focus points, when that's added together, that distance is constant. No matter what point you move around the ellipse, it's always adds together to be the same distance. So for a hyperbola, it's very similar, except it's the difference. It's not the sum. It's the difference. When we subtract the difference of one from the other one, we always get the same number. So a hyperbola is the set of all points, x, y, where the difference of whose distances from two distinct fixed points, which are the foci, is constant. So each hyperbola has two branches. It's kind of like two back-to-back parabolas, but they're not really parabolas. It's a hyperbola. It's a little different shape. But they're not connected, and they're kind of back-to-back. The vertices are intersected by a line that goes between the two focus points. That's called the transverse axis. It's not, we don't call it like a parabola. We talk about the axis of symmetry. We call it a transverse axis with a hyperbola, although it really is axis of symmetry. It will cut it in half. And the midpoint of that line between the two hyperbolas is the center of the hyperbola. So hyperbola has two parts. It's really not two hyperbolas. It's one hyperbola. And as with the other conic sections, there are two forms of a hyperbola. There's either horizontal or vertical. And the ones shown in the illustration here are both horizontal. I mean, it goes left and right. See, our illustration is for a horizontal hyperbola. If you rotate it 9 degrees, it would be a vertical hyperbola, which would be up and down, and the space would be in between there. So let's look at the standard equation for a hyperbola. It's very, very similar to an ellipse. We just changed the sign. So here it is. X minus h squared over a squared minus y minus k squared over b squared equals 1. This is exactly what we saw on the ellipse, except it had a plus in the middle. That's the only difference. And this is for a horizontal one. And for a vertical one, we switch it. And again, A is always larger than, it says, note that the equation is for hyperbola. Unlike an ellipse, A is not always necessarily larger than B. Not always necessarily, but we'll have x minus h over a squared minus y minus k squared or b squared for horizontal. And then they swap the numerators for a vertical one. So, and again, if the center is at the origin, if it's at 0, 0, that simplifies our equation because h and k are 0. So it's just x squared over a squared minus y squared over b squared equals 1. Or swap the numerators, make it y squared over a squared instead. As with parabolas and ellipses, we are frequently asked to write the equation of a conic section and give relevant information. So, as with an ellipse, we must find the h, k, a, and b. So let's look at this. So let's look at the illustration a little closer here. Let me blow this up as much as it lets me here. I can't blow it up much more than that. So we see here the distance 1 plus distance 2 is what they talk about. We subtract that, you'll get the same number everywhere. But I'm going to go down and look at this. A is the distance from the center to the vertex. Remember that the center is going to be on the same line as the vertex and the two focus points. So the foci, vertices, and center are all going to be on the same line. So the distance is A from the center to a vertex, and the distance is C from the center to the focus point. Yes. Center to vertex is A, center to focus point is C. So it's important to know those pieces if we're going to be able to find the equation. So let's go down to test our skills. From the standard form of the equation, it has a hyperbola that has focus points at -2, 4, and 8, 4, vertices at 0, 4, and 6, 4. So let me grab my pencil, write that down real quick. All right, foci at -2, that's supposed to be a 2, -2, 4, and 8, 4, vertices at 0, 4. So let's find where the center, because the center will give us h and k, right? So the center is going to be halfway between the focus points or halfway between the vertices. It'll be the same either way, right? So if we find the midpoint between these 2 points, they have the same y. They're both at 4. So that tells us that our hyperbola goes this way because they're both on where y equals 4, a horizontal hyperbola. So if the y is going to be 4 regardless, because 4 plus 4 divided by 2 is 4. So 0 plus 6 divided by 2 gives us the center at 0 plus 6 is 6 divided by 2. 3, 4 is our center. That is our center right there. So from the center, remember from the center to the vertex is A. And from the center to a focus point is C. And again, we can find A squared minus B squared equals C squared to find the other point there. So let's see how far it is from the center to a vertex. So we can pick either one. It doesn't matter. So let's pick the second one. Let's go from 3, 4. A would go from 3.4, 3, 4 to 6, 4. Well, how far it is it from 3, 4 to 6, 4? You have those points. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. If you're at 3, 4 and 6, 4, the only distance is how far is it between those two x's. From 3 to 6, our A must equal 3. Our A must equal 3. So let's find what our C is. And that's from a center to a focus point. Well, our focus points are -2, 4 and 8, 4. So it'd be easier to work with 8, 4, I think. And our center again was at 3, 4. So how far is it from 3, 4 to 8, 4? Well, that's a distance of 5. All right, so that's a distance of 5. So let's see. If we know that C is 5 and A is 3, we know that a squared minus b squared equals c squared. But if we get b, we need to know what b is, or b squared, really, because our equation is going to be, if you remember, the x minus h. I see ours is horizontal, so the x minus h squared is going to be over the a squared, and in this case 3 squared, minus y minus the k. Let's see, and our h is 3 and our k is 4, so it's x minus 3 y minus 4, and this is over b squared equals 1. We need to know what b squared is, so let's subtract a squared from both sides. So that gives us negative b squared equals c squared minus a squared. We divide both sides by -1 because we don't want negative b squared. We want positive b squared. So that changes the sign of both these. This becomes a negative and that becomes a positive. So b squared, since a is positive, we'll put it first. We'll just rearrange. It doesn't matter. We can rearrange that. So b squared equals a squared minus c squared. So a squared, our a is 3, a squared minus 25. It's going to be the absolute value of this because we can't have a negative. Negative 16, but the absolute value of that is 16 because we're talking about a distance, so we can't have a negative value in a distance on a distance like that. All right. So if b squared is 16, we can replace that in our equation. Or we could have done 4 squared, either one, but simplify that. X minus 3 squared over 9. We'll simplify this. 3 squared is 9. Minus y minus 4 squared over 16 equals 1. All right, let's check and see how we did. Find the standard form of the equation as the focus of these points for to see. Check our answers. X minus 3 squared over 9 minus y minus 4 squared over 16 equals 1. That is the equation we came up with. So you see how they did that? They did c squared minus a squared. Come up with the 16. Again, you got to have a positive value for that. So we come up with the correct equation. Oh, it does have c squared equals a squared plus b squared. So it would end up c squared minus a squared. All right. Let's talk about the asymptotes. Asymptotes, that's a nice mathematical term. Let me see. See this graph here? This doesn't have the asymptotes. I think I have one that has asymptotes, but let's look at this here. This is an illustration I found on GeoGebra of a hyperbola. The hyperbola is in black right there. You see that? And here's the focus point. And the other focus point on the other side. Notice the focus points are inside the two curved parts of the hyperbola. And then the center is out here at 0, 0 on this one. We have a center at origin. So it has the equation down here. X squared over 1 minus 1.5 squared, because that's what our A is set. Let's change our A to like 2. And we'll change our B to 3. Let's just give some bigger numbers here. Okay. So when you do that, x squared over 4 minus y squared over 9 equals 1. Here's our two focus points. One's at negative 3.610, and the other one's at positive 3.610. Origin of center. Negative 2, 0, and 2, 0 is the vertices. But let's look at this. The distance from this point on the hyperbola to this focus is 9.38. And the distance here is 5.38. And when you subtract those, remember, with an ellipse, we add those. With a hyperbola, we subtract those. The distance is 4 when we subtract those. So let's move this point and watch what this distance changes to. Oh, it doesn't change at all, right? Because that's the definition of a hyperbola, is that the distance between these points, any point on the hyperbola and the focus, is always going to be the same. It's always going to be 4. We can move it over here. Doesn't matter which side it is. Move it on the left, move it on the right. It's 4 either way. when you subtract the distance from a point and the two foci, it's always the same number, either side. We put it right here on the vertices. See, it's still 4. Put it wherever. But let's talk about the asymptote now. So an asymptote, let me draw that real quick. We've talked about an asymptote when it comes to when we did like logarithms and exponents. You know, we'd have that where there could be an asymptote where this would be getting closer and closer and closer to the y, but I mean to the x, to y equals 0, but it would never touch it because this line here is an asymptote. Well, with a hyperbola, we have asymptotes that, but we have two asymptotes. So let's say if we graph a hyperbola, and the hyperbola looks something like this. Trying to make those look the same.
All right, guys. Okay, so when you
there are actually two asymptotes. One of them will go this direction.
Okay.
If I did that okay. And one of them will go this direction.
Okay, let's put these cubes.
And that hyperbola will not touch either line. Now again, ignore my drawing, but this would be getting closer and closer and closer to that asymptote. This will be getting closer and closer and closer to the asymptote this direction. That'd be getting closer, this would be getting closer. So all four of these ends would be getting closer and closer to those asymptote lines, but would never touch. So asymptotes exist in more than just exponential and logarithm equations. They also exist in hyperbolas because you have that line that will never touch. So here's how to find that asymptote. If it's a horizontal transverse axis, and remember the transverse axis is what we would call the axis of symmetry. With a hyperbola, we call that the transverse axis. Transverse. So in this case, it's right there in the x-axis. So it's horizontal. Then you take the k, and there's two asymptotes. That's why you have a plus or minus. K plus b divided by a times x minus h, and k minus b divided by a over x minus h. For the y, for the vertical transverse axis, it's y equals k plus or minus a over b, x minus h. You just swap the a and the b. See, on the horizontal, the b was on top of the fraction. On the vertical, the a is on top of the fraction. So keep in mind, these asymptotes are straight lines, and they will fit into the point slope form, y minus y1 times m x minus x1. Or y equals mx plus b, right? The point x1, y1 is the center of the hyperbola. The slope m is the change in y divided by change in x, which is the ab or ba. That gives us the slope right there. So this wants us to find the coordinates for the foci and vertices for the hyperbola given by this. Wow, look at that. Find the equations of its asymptotes. All right. So we've got a lot of things to break down on this. We've got x squared and y and x minus 4. Let's find the equations of its asymptotes. Which means to find the equation of asymptote, we have to know h and k and a and b. All right. H and k and a and b. So let's work through this and let's look at their solution, how they did that, just to give us directions to go. So first you have to complete the square to put the equation in standard form. It's not in standard form yet, right? We need to get it looking like this because that's how we get our h and k. So with standard form, with completing the square, let me go ahead and write down this equation because we probably need to do this step by step together on paper. Okay. So let me move that away. Get our camera back up here. So there's the equation. So instead of just seeing their steps already done, let's work these together step by step so you can see how I did. So we need to complete the square. So we're going to group these then. We're completing the square. You group the x's and the y's. We see right away with our y's, we can factor out a 16. So you have y squared minus 2y minus, there's nothing to factor out of here. I mean, we want to leave the x in there. We can factor out an x, but that defeats the purpose of completing the square. Equals 4. Okay, so remember, completing the square is when if you had like a x plus 4 times x plus 4, completing the square means you're creating a perfect square, which means you have two binomials that are the same that creates that trinomial. So this would be a perfect square trinomial. Equals 0. See, that's a perfect square trinomial because this breaks up into two identical factors. That's called a perfect square trinomial. And we're trying to create perfect square trinomials here. So if you remember, we took the middle term, the 8, and we divided it by 2. I'm sorry, we divided it by 2. I put those numbers backwards. I'm saying one thing and doing something else. Divide it by 2, which equals 4, and then we square that number, and we get the 16, which is what gets added on there and subtracted from the other side, coincidentally. So we're going to find out what this number is. Here we have a 2, a negative 2 specifically. But when we square it, it doesn't matter. So if we have a 2 and we divide that by 2, that's negative 1. And when we square that, it's just a 1. So we need to make this 16 y squared minus 2y plus 1. Right? Which means we need to go over here and we got to add that 1 on the other side too. Because otherwise we've changed the equation. Whatever we do to one side has to be both sides or it's different. And we're not trying to change the equation. We're just trying to rewrite it.
What? Mr. Brugg, I'm so confused.
What's that? Rewriting? I mean, completing the square?
I'm so confused since you started like the explaining at
Okay.
the top right.
Okay.
Whatever you-
Let's ignore this for a moment and go through the process. So ignore this for a moment.
Okay.
So we've got our y's grouped together and our x's grouped together.
Yeah.
And we're trying to create and make a perfect square trinomial from that. So we take this y coefficient,
Okay.
not the y squared, and we divide it by 2 and then square whatever we get out of that. So which is right here. Negative 2 divided by 2 is negative 1. And then we square that, so we get a positive 1.
But just because?
Just because. And so
Okay.
it gives us a number, and we add that plus 1 into the equation.
Okay.
Right there. We also have to add that to the other side, right? Because we're not trying to change the equation. If we do something to one side, we have to do it to the other side.
Yeah.
Or we've changed the equation. And you'll see why we do this in just a minute. We got to do the same thing with the x. So our coefficient of our x term is negative 4. So we're going to divide that by 2. We got negative 2. So now when we square the negative 2, that gives us a positive 4. So we're going to add 4 to both sides. What am I doing? Am I making a video on a Monday morning? Not even awake yet. All right, let's stop it right there and fix these errors before it gets any worse. Because I got off base on there, obviously, and was not properly thinking. So let's back up just a touch right here. Back up to this step where we had this right here. We had it at 16 factored out. The 4 is on the other side. It's a positive 4. And we were completing the square with these two terms. So we did have properly taken the negative 2, dividing it by 2, and that's a negative 1. And that will end up being the term that we have down here. y minus 1 squared for the next term with the 16 out front. But when we take that negative 1 and square it, positive 1, that is the number that would complete this trinomial and make that a perfect squared trinomial by adding the 1. So now that would factor to this binomial squared, which is why it's a perfect square. We wanted to create a binomial squared. So to add a 1, that will do that. Now here's the problem. In my original video, I added the 1 on this side. But that's not totally correct because I didn't add 1 to this equation. I added 16 because whatever's inside this parentheses is being multiplied by 16. So I have to add 16 to this side of the equation to keep it balanced. If I just add 1 over here and I add this plus 1 inside the parentheses, that means I've actually added a value of 16 to this side. So I have to add 16 to that side. So that was the first error I did. I added the wrong number over here. Secondly, and let's do this as a second step. Okay, so second step, when I've got to this part, let's pretend we're going to have it factored. It doesn't matter if it's factored yet or not. When I want to complete a perfect square trinomial on this side, all right, and I've got 20 really. I'll do the 4 plus 16 just to keep it clean. So here, my coefficient is negative 4 divided by 2. Negative 2 is the number that's going to end up here. It's going to be x minus 2 squared, because that is the number I get when I cut that in half. But the number I add on to that is negative 2 squared, which is 4. So I have to add 4. So in my original video, let's go ahead and write these other factors here. Equals. In my other video, I added 4 here and I added 4 here. But here's the problem again. I'm not adding 4 to this side of the equation because this is being subtracted. Everything inside here is being subtracted. So when I put a plus 4 in here, I'm actually subtracting 4 from this side of the equation. Up here, I was just subtracting x squared, adding 4x to subtract a negative, and then 0. But now I'm subtracting 4, so I have to subtract 4 from the other side. These two things I did not pay attention to. I was not awake this morning to catch those things until I looked at it later and went, well, yeah, I totally skipped that. So if I do that, 4 minus 4 goes away, and this does equal 16. So I'm not quite to the equation of a hyperbola. I got to divide everything by 16 because I need this just to be the y and the x on top. So if I divide everything by 16, that means I have to divide this by 16 because I got to divide everything on both sides by 16. So this just becomes y minus 1 squared minus x minus 2 squared over 16 equals 1. And the equation of a hyperbola should equal 1, just like on a circle, it equals 1, like plus, that's a circle or an ellipse. So this is the correct answer when you do these steps right. Just remembering it from factoring the square and adding. If I have something outside multiplying it, that changes what I really added. I really added 16, and I really subtracted 4 here. I subtracted 4 just because there is a minus of 4. So to balance it, I have to be sure I'm putting the right things on the other side of the equal sign as well. That's where they had a 16 on top, and I'm not sure how they got that. We'll look at theirs in just a minute. So theirs would equal 1 because they had 16 divided by 16. This would cancel out because if you multiply it by 16 divided by 16, you got y minus 1 squared minus x minus 2 squared over 16 equals 1. So when you look at this, the center, y minus k, x minus h, the center is at 2, 1. So that gave us our h and k. Right, that's our HK 2, 1. And then once we know that, we know a squared is 1, because this is just divided by 1. So that means our a is equal to 1. And our b squared is 16. So b is equal to 4. We know it's not negative 4. The square root of 16 is 4 or negative 4, but we're talking a distance. And we would not have a negative distance. So there's our a and our b and our h and our k. So let's look at what they did on this, because I still want to know how they got that 16. So looking at their math right here. So they had the same thing we did. Y squared minus 2y. And they added 1. Which means they would add 1 over here. But they've added 16 for some reason. I don't know how they've done that. On this one, we had x squared minus 4x, and it's added 4. And they added 4, and I don't know where this negative 1 came from. I'm going to have to check into that. But anyway, they still end up with the same a and b that we have, and the same h and k that we have. So those points didn't change regardless of what they did over here. So the y term is positive, right? This is the y term is positive. So the transverse axis is parallel to the y-axis. So this is an up and down vertical. A is the distance from the center to the vertices. So the vertices have to be at 2, 0, and 2, 2. See, notice there it's up and down. So the y is what changes. One vertex is below the center, one's above the center, because our center was at 2, 1. So straight below that at 2, 0 is one of the vertices. Straight above that at 2, 2 is the other vertices, because the distance is a equals 1. 1 is the distance between the center and the vertices. All right, we can draw that real quick. If 2, 1, just to give you a visual. If 2.1 is the center and a equals 1, a is the distance from that to the vertices. So it's just 1. There's one vertice, and the other will be right here. That's the 2 vertices, which means that's the point that the hyperbola is going to come down through. That's the 2 vertices. And then the distance from the center to the focal point is C. So we have to figure out what C is. We have A and B, so we can do that. So they did that right here. C squared equals A squared plus B squared, which is 1 plus 16, because we have those. So the square root of 17. So this gets a little complicated, is that the distance from the center to the foci are at 2, 1 minus the square root of 17, and 1 plus the square root of 17. All right, so those are kind of complicated points, but that is what the distance equals. That's the square root of 17. 17. So 1 would be adding that distance. It's already at 1. It's at 2, 1. But we got to add that distance, add C to it. So add the square root of 17. Which, if we convert it to a decimal, it's going to be off, because you'd have to round it. That is not a nice terminating decimal. And then we have to subtract that distance for the bottom focus point. So it's 2, 1 minus the square root of 17. Now we can get an estimate of where that is by putting it in the calculator, but square root of 17 is a little bit over 4, because square root of 16 would be 4. So this is just a little bit bigger than that. So if you want to know where that would be, 1 plus 17 square root. So it's about 5.123. If you was graphing it, that would be where one focus point is. And then the other one would be at 1 minus square root of 17. So it'd be done at negative 3.123. So that would just kind of give you an idea, if you're graphing it, about where to put those 2 points. If you're not graphing it, leave it with the square root of 17 as as your answer. This would be your, if I just asked you for the points, you would give me these points. If I asked you to graph it, then you'd convert it to a decimal so you would know where to graph it. So it'd be up here about 5.123 and be down here. But it should be the same distance from the center both ways. Now, using, the whole question just asked us for the equations of the asymptotes. So we just have to know this right here. This is a vertical transverse axis. So we know the equation is y equals k plus or minus a over b x minus h. So we didn't really even have to figure c, but they did that. So I wrote that down. So if that's the equation, we know xh is 2, 1. I'm sorry, hk, because that was the center. We know a equals 1 and b equals 4 because a squared was 1, b squared was 16. So a is 1, b is 4. So using this equation, we have one horizontal asymptote at k is 1 plus a over b 1/4 x minus 2, which we can simplify that. Y equals 1 plus 1/4 x, and 1/4 times -2 is minus 0.5. I shouldn't do that. I shouldn't put a decimal and a fraction in the same one, right? Minus 1/2. So if we want to put in the mx plus b, 1/4 x, 1 minus 1/2. So there's the mx plus b, 1/4 x plus 1/2. The other asymptote is going to be at y equals 1 minus a over b, which is 1/4 x minus 2. So y equals 1 minus 1/4 x minus 1/4 times minus 2 would be plus 1/2. So the other one's going to be at negative 1/4. Notice it's sloping the other direction. This one's sloping positive 1/4. This is negative 1/4 plus 1 1/2, or 3/2 if you prefer. So that's the two. Let's see if that's what they got. See if we did something wrong or if that's what they got in there. Check your answers. Did they simplify it all? Oh, they left it at this. They didn't even simplify it. They said plus or minus the 1/4 x minus 2. So that's fine. You can leave it like that. So we had that right here. 1 minus 1/4 x minus 2 and 1 plus 1/4 x minus 2. So that's the same thing as 1 plus or minus 1/4 x minus 2. Without having to go into all the simplification. So that's probably the easiest way. And if you have multiple choice assignment here, it's probably going to give you this form here instead of simplifying it further. It's probably going to be that. But don't be surprised if they change it on you. It's just getting rid of the parentheses. That's all you're doing. Get rid of the parentheses and simplify. So what else we have here? We finished the section, the table that summarizes it. Much like we had on the ellipses and the parabolas, we have a table here. If it's parallel to the x-axis, the transverse axis, right, which means it's a horizontal, then your focal points, your foci, is at h plus or minus c, k. You just take c and add it to h. That's one focus point. You take c, subtract it from h, and it's the other focus point from the center. The vertices is you add or subtract a from the h to get the vertices. Gives you the equation, and it gives you the asymptote equation over here. If it's parallel to the y-axis, it's an up and down center focal point line. Then you take the c and add it to the k, and the a goes with the k. And there's the equation for that one, where again, just the y minus k and the x minus h trade places. And the equation a over b instead of b over a. Okay. If you see the equation look like this, and this is kind of in standard form, where you have the x squared plus the y squared plus the x plus the y plus a constant equals 0. So if it's set equal to 0, here's some things to kind of tell you what shape it is. Because looking at this equation, there's no way to tell what shape it is unless you know this stuff here. If a and c are equal to each other, you see an equation where a and c, so the x squared and the y squared have the same coefficient, 5x squared plus 5y squared. It doesn't matter what these other ones are. If it has those two things, it is a circle. If a times c, if you multiply those coefficients together, it equals 0, which means either a is 0 or c is 0. One of those don't exist. You may just have an x squared or may just have a y squared because the other one has a coefficient of 0. Then it's a parabola, right? It's either an up or down parabola or a left or right parabola. If a or c is missing, right? If one of those is 0. It's an ellipse if a times c is a number that's greater than 0. A and c will have like signs if it's greater than 0. If it's less than 0, it's a hyperbola. And they will have unlike signs because you'll have a positive times a negative to get a number less than 0. So that's how you can tell which of those 4 shapes you're dealing with when you just see a nasty old equation like that. It has x squareds and y squareds and everything on the same side, set equal to 0. But all you really care about is the a and the c. You don't have to worry about what d or e or f is. All you need to know is what the A and C is. So this is a nice little cheater chart to have, along with this little table above that to help you with hyperbolas. And it gives you another one where you classify each graph. So you can look at this. I'll leave that one for you to do on your own. Check your answers. You just use this little code right here. Look at this and say, what is this? This is a 25y squared minus 4x squared. So this has an A and a C. So it's not a circle. They're not equal. It's not a hyperbola. One of them is not missing. It's not a 0. Both of them have a number. It's a -4 and 25. So it's either an ellipse or hyperbola. So I'll leave those for you to look at. But that is all of that. Let's shrink this back down a bit. Okay, let's look at the assignment that goes with this. It's just multiple choice. 1, 2, 3, 4 questions. Has one where it wants you to find the vertices and foci and gives you a hyperbola. Find the vertices and foci, gives you another hyperbola. This first one's got a center of the origin, so it's simpler. This one, they move it off of the origin to make it a little more complicated. Then they give you an equation and ask you which one of these is the graph of that equation. Looking at, first off, the center was HK.
Yes, very good.
This has the center of the origin. The equation is not centered on the origin. So if you look at that, a lot of times it looks like there's only one that would have the correct center. You don't even have to look at anything else. You don't have to look at A or C or anything. Only one of them has the correct center. And the last one, find an equation in standard form, and they'll give you the vertices and the foci, and you got to figure out which one of these equations it is. So that is assignment 6.03. But I want to look at the conics collage. So this is one of those where you're going to do like on a Google Doc or however you want to do this on paper. It's easy to do a Google Doc because you can pull in pictures because you're making a collage. A collage is a group of pictures put together. So here's the instructions for that. Find at least 3 examples of conic sections in the real world. You're looking for circles, you're looking for ellipses, you're looking for parabolas, you're looking for hyperbolas, right? In architecture and buildings, just in nature, wherever you find it. Marketing ads. And make sure your collage demonstrates at least 2 of the categories. So you can't have 3 circles. If you have 3 circles, you also have to add another shape because you got to have at least 2 different conics among your at least 3 examples. You can give more than 3 examples, then you're going to have 3 circles because you might add an ellipse also. So you can use circles, ellipses, parabolas, hyperbolas. Put your images on paper or in a Google document. Like I say, it's probably easier to just copy and paste them into a Google document. So you can create it using however you want to, scanned image, PowerPoint slide, word processing, Google document, whatever. But you're going to get these pictures together. So then you're going to write a description about one of the conics from your collage, right? This is the shape of a hyperbola. You can see right here the curve and the curve, whatever. Just describe one of them, just one. And then write the equation that represents your conic in its standard form. If it's a circle, you got the x squared plus y squared equals 1. Or if it's not on the origin, but you're not graphing it. So it's the x squared plus y squared, To do this, like if you have something that's a circle, you go out there and you find a big Ferris wheel. Hopefully it's a famous Ferris wheel that you can look up and find out what the radius is, because you got that equals r squared, the radius squared in a circle equation. You need to know what the radius is. If you put equals 1, that's going to be wrong, because I know your Ferris wheel has larger than a radius of 1 foot or 1 meter or whatever measurements it's given in. So it needs to be accurate as much as possible. If you cannot find it, just give a good guess. Oh, that Ferris wheel is 100 feet high. And you can put that in your description. It says 100-foot tall Ferris wheel. So then I know 100, you're going to use that as how tall it is. So your radius is 50, and you're going to use that 50 for your radius squared. But it's got to be something, either a guess or finding out exactly from Googling it how big it is. And like a lot of these, you can. Like some people before have used the London Eye, or there's one over in China or Hong Kong or Japan, somewhere they've got a really big one too. And so you can find the measurements of it. So here's what you must include in your paper that you turn in. All right. Your conics collage, your pictures, a description of one of the pictures, the standard equation of one of the conics, and then you can say how you found the equation, explanation. I used the equation of a circle. I know what the radius is, and that's how I made it. If you look up information, where did you find that? Like I looked it up and I found out that the London Eye is 300 meters tall. I looked it up on this website. And then there's a rubric. So you can click on that. It'll give you the rubric. It didn't recognize my session because I've been changing pages. But anyway, as long as you have these things, you're fine. Conics, a description of which one you're doing, because your conics is going to have more than one. That's why you're describing one of them, because you're going to have circles, ellipses, parabolas, hyperbolas, at least 2 of those things in your collage. And then what the equation is. And you can just assume that the center is the origin. You can just assume that. That will simplify. That will make your HK 0, and your equation gets very simple if you don't have H's and K's. So you can assume it's on 0, that if you were graphing it, it's a 0. So that is the conics collage. It's worth more than the multiple choice. So make sure you get that turned in, and it is due Sunday also. So you have 4 questions and a collage to do this week. And then we're back to the end of the test. So what does that mean? If next week is the test, that means if you're missing anything from module 5, you have until the end of next week to turn it in, or it is forever a 0. So if you're missing stuff from module 5, you're running out of time to get it turned in, because once we get this test taken, module 5 is closed. So late work will no longer be accepted for module 5 after the end of next week when we have the exam. That's all I'm throwing out. But we needed to cover that and make sure you understood it, because that collage is worth more points. You want to get that right. So, all right, guys, go enjoy your Monday. If you can enjoy a Monday, I guess you can. Yeah, go do that.